Alright guys, today we are solving problem 1726 tuple with same product. It's a Leetcode medium and a pretty good problem. Given an array nums of distinct positive integers, return the number of tuples a, b, c, d such that a product b is equal to c product d, where a, b, c, d all are elements of none and all are distinct numbers. So if you try to do a brute force approach for this problem, you could come up with a solution that resembles the two-sum problem, where you have a lookup and for each element you check that is the uh, target operator the current number in the lookup. If it is, we have found a pair, right? So I tried that solution, and I mean it's kind of O of n cube solution, so I didn't expect it to work, but it worked for around 32 test cases out of 37. So I thought about it and checked the hints. So hint 2 is actually pretty good, and uh, so the main idea behind this problem is the numbers are distinct. So there's only a few ways you could get a certain product, right? So for example, in the first example, you can get the product 12 by using 2 and 6 and 3 and 4. So these are distinct numbers, and what we can do is we can just keep a count of how many numbers are able to form 12. So uh, for the first example, we have 2 comma 3 2 comma 6 and 3 comma 4. So there are the frequency of pairs that form 12 is 2. Similarly, in the second example, we have 1 comma 10 and 5 comma 2 and 2 comma 10 and 4 comma 5. So the frequency of numbers forming the product 10 is 2, and the frequency of pairs forming the product 20 is also 2. So you have you have to choose two out of those uh, out of that frequency. So in PNC we have the concept of NC2, where you have to choose two from n different elements. So it is kind of similar in that way, and after we choose two pairs, we essentially have eight tuples for each. So we can just multiply the result by 8 to get our answer, and it might be better if I show it in the code. So we have n equal to length of nums, and we have for I in range n minus 1, for j in range 1 I plus 1 to n, and we are going to declare a frequency default deck. And for each pair we are going to count its frequency. So for frequency of nums of I times nums of j is equal to 1. So after we get the frequency, we have to, so if we get x as the frequency for a product, we have to choose two from it. So we can define a function called nc2. It takes a num and it returns the permutation nc2, which is num times num minus 1 divided by 2. And for key comma value in frequency dot items, for each value we uh, let's declare result as 0. For each value we add nc2 of that value to our result variable, and in the end we just return 8 times the result. and let's submit it. Works and is pretty efficient. I am sorry for the bad explanation, but you can give it to try yourself and try to make up your mind that this kind of works. So yeah, see you tomorrow.